Good afternoon, everyone. Welcome to this talk, which we've entitled Maps API Best Practices.
Or How to Be Awesome.
My name's Fletcher. I'm a software engineer on the Google Maps API based in Sydney.
And I'm Susannah Raub, also a software engineer on the Maps API team in Sydney.
So I want to give you a brief overview of our talk. We've broken it up into three sections. The first section we've entitled Be Smart. And this is some general development tips, some good tools that you can use to make your programming really robust with the Maps API.
And the next part, we're going to talk to you about how to be savvy, how to use some interesting features to solve problems in your application.
And the last section, and this is the section I'm personally really excited about. Are you excited about it too, Susannah?
I'm very excited.
This is the section we've entitled Be Awesome. And this is where we're going to take you through some advanced features of the API and using some different services in concert to create some really powerful applications. All right, so let's get started with Be Smart. And we're going to start this in a kind of an odd place, because we're going to tell you first when maybe you shouldn't be using the Maps API. And that's an odd thing to start off with in a talk about the Maps API. So here, what I want to do is I want to add a marker to the map showing where my favorite beer store in Australia is. And to do this, I've loaded up the entire JavaScript of the Maps API. We've got a panable map. It's got Street View. It's a big download. And all I really wanted to do was to put a marker on the map. And maybe this is overkill. This might be a situation where the right tool for the job is actually the static Maps API. And you can see here in this example, we've got just a static image of Bridge Road in Richmond, which is where Slow Beer, my favorite beer store, is. And it's just got a marker on the map. And this is really simple to do in static maps. And this is just a single URL that you embed in your web page, and it returns an image. But you might say to me, well, I'm not just going to Slow Beer. I want to go on a bit of a beer crawl. I want to go to my favorite pub that's near there. I want to go to the Mountain Goat Brewery, which is nearby. And I want to be able to show my friends the path that you can take to walk between the three. And the good news is that the Static Maps API allows for this too. It actually has a lot of visual elements that you can add to the map. So in this case, you can see we've got different colored markers with different labels on them, and we've got a polyline showing the path that you can take to go to all three of these great beer places in Melbourne. So to do this, it's really simple. The key parts here, we've got the three different markers with the different colors and the different labels, and we've got the path, which sets the route we're going to take.
Now, Jez and his friends are wandering around Melbourne all carrying their smartphones. And as smartphones get smarter, they also are having higher resolution displays. And with this, when an image is displayed, they upscale it in order to fill the device. And so the Static Maps API supports high resolution imagery as well. You can supply a scale parameter to get this image, which is the same as the one we saw before, but in higher resolution, which means that when the images are upscaled, we don't lose the pixel quality, we don't get blurry images. They will still be crisp and clear. Okay,
but let's say I want Street View imagery. The door of the Mountain Goat Brewery is in a sort of industrial area, and it's just a roller door, and it doesn't really look like a place you can actually go and get a beer. So I want to be able to show my friends, well, this is what it actually looks like, and this is where you want to go after you visited the Royston Hotel. So we have a solution for this as well, and this is the static Street View Image API. And this gives direct access to the image data from Street View panoramas. This is really easy to use. It's done in a very similar way to static maps. The key differences being that you request from Street View rather than static map. And you also have to set the orientation. So you can set a location just like you do for static map, but you also have the heading, the pitch, and the field of view. Now let's say I have some data on my server about all of the breweries in Australia. And I want to be able to dynamically load information about a user's top 10 breweries and plot them on the map and do some extra information. So there are my top 10 favorite breweries from Australia. The naive way of getting this data dynamically from my server is to make a bunch of individual HTTP requests, one for each of the documents that I want. Now this can be something of a performance hit because there's overhead involved in making each HTTP request. And we can see that if we do a net trace on one that loads a whole bunch of small documents, then we get a net trace like this, and we can actually harm our performance. So a better way is to have a handler that can actually bundle responses. And this is something we're going to hark back to a number of times in this talk, how you can make fewer HTTP requests to a server. So in this case, we've got a handler on our server which can cope with lists of IDs. And instead of making one request, we just concatenate all of the IDs that we want. The server will bundle those documents that we want and send them back to the client. This can have significant improvement in our performance, but there are some caveats to doing this. There are built-in limits to how long a URL can be. So if we just naively start concatenating IDs onto a long request, then we could come up against this limit. We should also keep in mind that we're going to be getting much larger responses back from the server. And so there's going to be some processing time required on the client to unbundle these. And of course, there's the processing time on the server to bundle these up, rather than just blindly serving a file. So as for everything, this is something of a trade-off. But you'll generally find that having fewer HTTP requests is a net gain for your application. That's a good rule of thumb.
Another way to reduce the number of HTTP requests that you're making is with your JavaScript, and to take many JavaScript files in which you're developing your different objects and classes and compile them together using the JavaScript closure compiler. The closure compiler takes a set of JavaScript files as input. It then checks them for validity and outputs more JavaScript that is a condensed form of what the input was. It strips white space, comments, and unused code. It can also do semantic and syntactic error checking before your code hits the browser, where the errors that you get may be fairly hard to decipher. It can also provide types through JS stock type annotations to provide for type checking in what is otherwise a dynamically typed language, and can be difficult in JavaScript that it's so dynamic and loose. It also optionally obfuscates or minifies your code by turning long variable names into short ones. So let's look at some of the errors that Closure Compiler can help you with before you hit the browser, and what might have happened if you were in the browser.
Right, so I've written this small application, and I ran it in the browser, and my app isn't working, and I got a really obtuse error message from the browser.
So Internet Explorer has a non-standard interpretation of trailing commas. And if you load something, an object with a trailing comma in Internet Explorer, you will get some random line number and some unknown error. Very hard to solve this problem. But the Closure Compiler will warn you of this and explain to you nicely what's going on and why it should be avoided. OK,
great. So I fixed up my trailing comma, but I'm still getting a whole bunch of errors, Susannah. Can't you help me?
So the compiler can also warn about undefined variables. So here, the parameter 2 was spelled TWO. I then used it as TOO. TOO is not defined. Closure Compiler warns me of that, instead of later getting just an undefined value somewhere else down the line, which would have happened if I'd been running this in the browser. And it warns me that I am using the this keyword in a function that has not been declared a constructor or is not a prototype method. So if we fix these up.
So I fixed these up. I've added the constructor tag. I've added some param tags. But I'm still getting errors, Susannah. So
now it provides the very helpful error that the new keyword is missing when you call my app. You cannot instantiate an object without the new keyword, but this is a very common error that we make. And often, your app will not throw any errors at all. It just won't work. So by running it through the compiler and being warned that we haven't called new my app, we've just called my app, we save ourselves a lot of time. Also, we've declared the function to have 2 parameter types and only passed in 1.
OK. So I forgot a parameter. That's a mistake that anyone could do. So I'll add the parameter. And now we're right to go, right?
It's still the wrong type. It was declared as a number. So this is how Closure Compiler enforces type checking. We said it should be a number. We passed in a string. That's bad. It's warned us. And again, if this were running in the browser, we would see some sort of, B does not support whatever operation we're trying to perform on it, instead of just letting us know where it was exactly that we passed in the wrong object.
OK, so I fixed this up, and now finally, are we ready to go?
We are. No more errors, and it outputs a minified version of this code, stripping all unused variables and functions.
Great, but I want to use the Maps API. That's why I'm here, right? So why is this code giving me so many errors?
So many errors, a slew of errors.
A slew of errors. This is really a slew of errors.
So,
in fact, next time I'm thinking of a canonical example for a slew of errors, I'm just going to think of this slide right here.
This is a slew of errors. So these errors are all saying that Google.Maps objects are not defined. Google.Maps, so you probably can't read these from where you're sitting. That's to make a point that there are a lot of errors.
But believe us that it's a slew of errors.
So it's all warnings that the objects of the Maps API are not defined. So the Clojure compiler supports something called externs. And externs is a file containing symbol definitions of things that exist at runtime, but you don't have at compile time in your own code, things that exist in third-party libraries. So the Maps API has an externs file, as do many other prominent third-party libraries. So when we download the externs file from the Clojure compiler site on Google Code and compile again using those externs, we get no errors. And we do get this minified version of our function. And you'll note that none of the Google Maps API properties have been obfuscated. Those need to be used in their full symbols in order to be recognized by the API. You can learn more about the Clojure compiler on developers.google.com. And there is a web service that allows you to run your code through the compiler right there on the web page. You won't get all of this neat error checking that I showed, so I do recommend downloading the compiler.jar file and running it on your desktop.
OK, we're going to talk a little bit now about testing. And this is an important part of any sort of application development, but it's something that's often overlooked in JavaScript development for the web. And there's no reason this should be the case, because there are some great tools out there for doing testing of JavaScript. The two main types of testing that we do in testing our JavaScript application, which is the Maps API, is unit testing and automated integration testing. Now, unit testing takes a single component and tests it in isolation. These tests are usually small, they're very focused, and they run very quickly. The advantage of unit tests is that they allow you to identify really easily what part of your code is not working the way it's intended to. The other good thing about unit tests is that when you're running a unit test alongside writing the component itself, then you're actually the first user of that component. And so it gives you a really good insight into how this component works, how it's going to interact with other things, and the interface that it actually exposes. The other side of this is integration testing. And this is where you test your entire application from end to end in the way that a user would actually interact with your application. And this tests the entire application. These tend to be larger tests, and they often run directly in a browser, in this case for JavaScript. The other great thing that integration testing is good for is checking for regression bugs. So one of the first things we do if we get a bug reported in the Maps API is that the first thing we do is write an integration test for that bug. And then we go in and we fix the bug itself, and then the integration test passes. And now that we've got that integration test as part of our test suite, it means that we shouldn't see that bug come up again in the same form that that we saw it in that case. So the two tools, these are actually the two tools that we use in the Maps API to test our code. And they're both available as open source libraries. The first is Google.js test, and that's what we use for all of our unit testing. And for our integration testing, we use a library called Puppeteer. And Puppeteer is really good because it actually runs your application in the browser. And you can actually watch it as it's running through the interactions it does with your application. And you can also then have a look at the DOM and interact with the page. If there's an error, for example, you can see exactly the state that the page was in when the error occurred. And they're both available to download from code.google.com.
So this brings us to some features that you can use in solving your problems using the Maps API. We're going to take these good maps you have, and we're going to make them great. So when Jez drags this marker you'll notice that the circle follows along with it. And just to point out for a moment, I want to show our circle object in the API that is drawn in geographic space, which is why it gets bigger as it goes towards the pole. Just kind of a neat little feature.
Hooray for Mercator projection, hey?
So that is an example of key value observation. Key value observation is when one object is monitoring a property of another object and updating its own state to reflect that. So we can implement this marker and circle following each other using an event listener on the marker, adding a listener to listen to changes to the marker's position, and then updating the circle center to match that of the marker. This is a one-way binding. If the circle changes its position for whatever reason, the marker will not move with it. So we have in the API something called MVC object, where MVC stands for Model View Controller, but it is more generally an object to help with key value observation. And the MVC object lets you set up two-way bindings between objects with one call. So here, the circle is binding its center property to the marker's position property. Anytime the marker's position changes, the circle's center will be that value, and vice versa. So both the marker and the circle can be changed, and the other will update. This is a fairly simple example, but here's something more complicated. Here I built a custom map type control, where the custom control actually shows what the map is going to look like. And I've used the styled maps API to do this. So when a button is clicked, it updates the map type ID, which is bound to the map. So the map and each of the buttons, which are MVC objects, share the property of map type ID. They know nothing about each other, but they just share this one property. So when the map's map type ID changes, each button is notified of that and can update its selected style, or its style to be selected or unselected. And when a button is clicked, it can update the map type ID, which is then reflected on the map and in every other button. None of the buttons know about the map, and the map doesn't know about the buttons. It just has one bit of wiring code that hooks up those bindings, just like we saw in the previous example, where each button is bound to the map's map type ID. Now, one great advantage of this is that it's much simpler to implement than adding a whole bunch of event listeners and passing the map around to all the buttons and having all these complicated class interactions. The other advantage goes back to the testing that Jez was talking about. Using key value observation in this way and using the MVC object makes for easier unit testing, since you can test the map in isolation and you can test the button in isolation. And the button doesn't need to know anything about the much more complicated map object. It only needs to check that when it's clicked, it sets the map type ID, and that when the map type ID changes, its styles reflect that.
OK, so if you've been to any of the Maps API talks in the last couple of days, you've probably seen this example before. But that's because this is something that we really want to drive home hard. I put the rhetorical question up on the slide, who's seen an address entry form like this? And the answer, of course, is everybody, because every form on the web looks like this. And we don't think this is a particularly good way of implementing an address entry form. We think this is a lot better, where we have the Autocomplete widget, which allows us to dynamically predict what address is being entered and then get structured information about this. So I'm going to type in the address of the office of Google Australia in Sydney. And when we select that, we get a whole bunch of information that we can use to pre-populate this form. So we've got the street number and the street name. We've got all of the information about the address, but we also get for free extra geographical information, such as the latitude and longitude. And this is really easy to implement. All that needs to be done is that you need to include the places library when you load the Maps API. And then you can just instantiate the Google Maps Places autocomplete and pass it the input element that you want to turn into an autocomplete widget. And then you just listen to the place change event on that widget. And then when a user selects a particular place, you can get the structured information out.
So here we see the autocomplete widget being used in conjunction with a map. Since it gives us that location data, that lat long for the address entered, we can enter addresses and then easily plot them on the map with a marker. So Jez is going to put in a few beaches here in Australia. And I'd like to take this time to point out that if Jez always wants to show these same beaches in Australia, or he wants to show all the beaches in Australia, and he's not looking for user input, then the autocomplete widget is not the way to go. And the geocoder is not the way to go, the client-side geocoder. In the case that you're showing the same results over and over again, that you need to geocode the same objects and you have a static set of them, you should use the geocoding web service, where you make a request that looks like this. There are 3 requests here, 1 for each of the beaches, and it will output JSON. And you should then take the lat long that is returned in the JSON and cache that in a spatial data store. So, switching gears away from geocoding, back to our beaches. You can see these are the same beaches shown on the map, but with a slightly more interesting marker. This is the iconic surf life-saving flag in Australia that denotes any beach. To use these custom images, we use the custom marker image class. And the custom marker image class allows you to sprite your images. Spriting is taking multiple images and combining it into one file to, again, reduce the number of HTTP requests that we make. Anytime you're going to load multiple images to be used in conjunction, they should be loaded as a sprite, as a single image. So here I've made a sprite of the beach flag icon and its shadow. And to use both parts of this in the marker, I create 2 marker image objects. The first argument to the marker image object is just the URL of this marker. For spriting, the key arguments are the second and third parameters. The second one is the display size that you want to show. So the flag is 20 by 32 pixels, and its shadow is 35 by 32 pixels. That's the second parameter. The third parameter is the offset of that part of the image within the greater image sprite. So for the flag, it's up at 0, 0, and the shadow is at 39 pixels to the right of that. So those are specified in the second and third parameters. The fourth parameter has nothing to do with spriting, but tells the marker where the image should be positioned to have, at which point should be the marker's lat long. So here, you want the bottom left of the flag to be at the marker's lat long. So you specify the 0 and then the left-hand corner of that, which is 32 pixels for the anchor. That's the fourth parameter. Now the marker image class also allows for scaling of this. So we can show this same icon at 3 different sizes without loading extra images. To scale the icons, we add a 5th parameter. And the 5th parameter is the entire size of the image. So if it's a sprite, not just the part you want to show, but the entire size, after scaling. So if the image was originally 57 by 34 pixels, we multiply that by 2. And we need to specify that in the 5th parameter to marker image. You also have to multiply the display size, the offset, and the anchor by 2. But the key part is adding that scaled size. And the scaled size is not required if you are not scaling the image.
Another new cool feature for doing custom markers that was only launched at I/O yesterday is marker symbols. And this allows you to draw markers dynamically using any SVG path and have them be more interactive and more responsive than you can with a standard marker image. There was a great talk yesterday on this called Advanced Maps Visualization, and I encourage you to check it out on YouTube.
So when one image or one symbol is not sufficient for showing your markers, you need to use a custom overlay. And a custom overlay lets you create the DOM structure yourself and combine elements. So here I've created some markers for countries that combine a flag, image, and a label, as well as some shadows and some pretty CSS. So to do this, I inherit from the overlay view class. And then I implement 3 methods. I need to implement onAdd, which creates DOM elements and adds them to the maps panes. I then use the draw method, implement the draw method, to position that overlay. And so I convert the lat long into map pixel coordinates using helper functions provided. And this function will be recalled every time we need to reposition the overlay. And then the third is just onRemove, where you clean up everything you did in onAdd.
OK, the next thing I wanted to do is I wanted to show you some of the beautiful sights of my hometown of Sydney. And I thought, well, the best way of doing this, obviously, is to use a street view panorama. And so I picked a location in Sydney that has one of the best views of Sydney that I think we have. And here it is. Except that's not it, is it? That's the side of the street somewhere. And probably what I actually wanted to show you was around in this direction, where we have the beautiful Sydney Harbour Bridge, the Sydney Opera House, and looking towards the Central Business District across the harbour. Now the problem with what we've done here is we've just naively set the location, but we haven't set the orientation, the heading of this street view panorama. So you can see when you create a panorama object, you pass in panorama options. So we set the position to be Sydney Harbour, but we haven't set the orientation. So we can improve this by hard coding an orientation. So in this case, we've said, okay, we want to be looking at 190 degrees, because that's the direction of the CBD from Kirribilli, where this panorama is located. So you can see we've added our point of view object to our panorama options, and it takes our heading that we've hard-coded. Now this still isn't a really great solution, because it's not very dynamic, and if you need to do this for a large number of things, then you're going to have to manually hard-code each of the headings that you want. A better way to do this is to calculate the heading automatically. And so you can see here we've got two boxes where you can set your location and what you want to look at. And of course, these are autocomplete widgets because we're entering an address on the web. And anytime we enter an address on the web, we should be using an autocomplete widget. So we set the origin to be the corner of these two streets in Kirribilli, and we want to be looking towards Sydney, the city. But the advantage of this is that it's now dynamic. So if instead we want to look at Old Mason Street, which is on the edge of the bay here in San Francisco, and we want to be looking at another beautiful bridge, the Golden Gate Bridge, then we can do that, and we've not had to calculate anything. This is all done automatically for us. And the way we've done that is by using the spherical geometry library, which you can get with the Maps API by passing a parameter at load time, just like you can for the Places API. And it has a compute heading option, which we use here, giving it the origin and the destination, and we pass that into our point of view object. Now let's say that instead of looking at something specific, we just want to be looking down a road. And we don't care particularly what we're looking at, but we want to be looking down the road that we're traveling down. Now, the good thing about the panorama is that it has a lot of information about the panoramas surrounding it. So each panorama object has a list of links that links to other panoramas from the current panorama. And so we've set our location here to be Times Square in New York. And we've said that we want to be looking approximately 180 degrees. And what this demo is doing, it's looking through all the links from the panorama and finding the heading which is closest to our target. So if we wanted to be looking north instead, it says, well, the closest heading is 28 degrees, and there's a link off that way. So we know that we're looking down the street. So this is also really simple to do, but quite powerful. You just have to listen to the links changed event, and this will get called anytime a new panorama is loaded. And once that's loaded, we can get information about the links, look through each of those links for the one that's closest to our target, and set the panorama to be that heading.
And now it's time to show you how to put a number of these features all together, or to be awesome.
I'm excited about this section. Are you excited?
I am. So we've got some help from a few of our teammates today to help explain the situations that we needed to solve and to build these apps.
They've got some problems, and we thought we could put the Maps API into action to solve these problems.
So first, we have our coworker, James, and he's been kind enough to join us today. He has an unusual fear of aliens and always wears a tinfoil hat, as you can see. But sometimes I'm feeling mean, and I walk around the office, and I take off his tinfoil hat, and he gets pretty upset.
It's really cruel. We've tried to put a stop to it, but Susannah, she can't be helped. I mean,
can't help it. So he thought, well, since I'm always taking off his hat, he's going to cover the roof in tinfoil. And he thought there's probably other people who have the same problem where they need to cover their roofs in tinfoil too, so he's starting a little side business for it. And I felt bad about the hat, so I built him this application to help him estimate the size of the amount of materials he will need to cover his customers' roofs. So I started by giving him an input field to put the address in, and I'm using the Autocomplete widget to do that. And then we go to that location, and you'll note there is no zoom control on the map, and that Jez did not need to zoom in or out to get to this beautiful picture of our roof in the Sydney office. I used the max zoom service to find the best zoom level, or the zoom level with the best satellite imagery at that location. So I zoomed directly to that spot, and then put the drawing control from the drawing library on the map, allowing Jez, or James later, to outline the roof and draw a polygon over that roof. Then, with the path of that polygon, I can use the geometry library to compute the area and compute the perimeter, because he's also going to do some gutters while he's up there doing roof work. So with the places autocomplete, I gave James a tool to find an address, then used the max zoom service to zoom the map to the most appropriate imagery, most appropriate level to show the best imagery. Then added the drawing manager to allow him to draw polygons on the map, and used the geometry library's compute area and compute length functions to measure the area and length. I had to do no math. I had to set up no click handlers. It was a very simple application to write using the tools of the Maps API.
Okay, so the next coworker that needs some help is Chris. And Chris is a bit of a hipster. Actually, he's a lot of a hipster, isn't he, Susannah? He's a lot of a hipster. And he's just bought a brand new fixie, only it doesn't have any brakes yet. And the problem is that he wants to know if on his daily commute there's going to be any really steep hills that are going to cause him problems. Because he doesn't have brakes, he's likely to careen off the road and break his Ray-Bans or something like that. So we built him this app here. This allows him to enter the two places that he wants to go between. Of course, they use the Autocomplete widget. And then we'll give him directions along that path. And once we've got the path that the directions are going to take, we can then use the elevation service to get the elevation data for that route. And we've plotted this here. So we can see that he goes up a hill for a while, but then it's a pretty gentle trip all the way down the hill for the hipster in his hipster glasses. So this also leveraged a number of services through the Maps API. So it uses the Autocomplete widget, of course. It uses the directions service to get the route, and then the directions renderer to show that route on the map. It also uses the elevation service to get the elevation along the path that we get back from the directions service. And of course, we also use a custom image to show the glasses so you can tell that it's a hipster who's doing this.
And then our last coworker who had a problem, Dave needed to do some home improvements.
He really did. I've been to his house recently, and boy, does it need some home improvement.
So he thought on the way home from work one day, he would stop by Bunnings. Bunnings is Australia's home improvement warehouse store. The thing is, in Sydney, there are a bunch of Bunnings, and Dave didn't know which one to visit. So we whipped up this app for him. Let's see work and his home out in Balcombe Hills. And then I used the place service to search for all of the Bunnings that are in this viewport. So these are all the Bunnings, and you can see there are a lot to choose from and a number of them that look like they might be reasonable options. Now, to find the best path, I could have made a separate directions service request for every single Bunnings to find the distance and duration it would take to travel that route. That's very expensive. It's bad for the user. It would take too long. It's too much data. Each directions result is quite large. It's not an efficient way to solve this problem. But there is the distance matrix service. And the distance matrix service takes a set of origins and a set of destinations and computes the distance and duration between each origin and each destination. So I set the work and home as the origins and each of the Bunnings as the destinations. Then I computed, using the results of that, which of these Bunnings resulted in the shortest trip between work and Bunnings and that Bunnings and home. Then I fired off that request, that single request, to the directions service. And I got back the full driving directions to plot on the map and in the panel. Now, both the directions service and the distance matrix service provide a number of options for routing. So the initial result told us that the Bunnings near Chatswood is probably or Crow's Nest, Chatswood.
It's actually in Artarmon. I looked it up.
It's in Artarmon. I can't even say that. So that's the best route, given that he just wants to drive. But if you know anything about Sydney, this route has a bunch of toll roads on it and would be a very expensive trip for Dave to get home. So we can send to both the distance matrix and direction service the request to avoid tolls. So avoiding tolls takes him to a North Rocks Bunnings. And if for whatever reason he wants to avoid all highways, it'll send him down this other road through Parramatta, going to the Auburn Bunnings. And here you can see that he probably actually has a few options for the Bunnings to visit. But the distance matrix said this one is best. And if he's feeling particularly environmentally conscious, he might want to walk, even though you'll see the route takes, I think, about 6 hours, and that doesn't include the stop at Bunnings.
And if you know Dave, he likes to spend a good couple of hours at Bunnings.
So that might be a long trip if he were to walk home. So to implement this, I use the Places service to get all the Bunnings in the viewport. I then use the distance matrix service to get the shortest route in using only one request, despite the fact that there are many Bunnings. Then I used the direction service to get the full details of that routing. And I used the directions renderer to draw that on the map and in the panel.
OK, so that's the last of our demos. And we just wanted to give you 3 key takeaways from this talk to sort of summarize what we were talking about. And the first takeaway we'd like you to think about is that you should be following good programming practices even when you're in JavaScript and even when you're just working with the Maps API. And we've shown you some cool tools with the testing open source libraries that we showed you and the closure compiler that can help you do this.
And then we want to encourage you to really pull in all of your resources. Use as many features as you can to enrich your data, to add context to it, and to create something that would have been smart and make it awesome.
Exactly. When you use features together, you really get powerful stuff, don't you, Susannah? And the last thing, and you've probably seen this before, we want to drive home that every address field on the web should use autocomplete. And you've seen that all the way through our demos. Every time we had to enter an address, we used the Autocomplete widget. And we think this is something that's not just going to make your Maps applications better, we think it's going to make the web better as a whole.
So you can visit developers.google.com/maps for more information about all of the APIs and features that we've talked about today.
And we'd now like to throw it open to questions. So thank you very much.
And if you have any questions, please come to one of the mics.
I have been... Hello? Can anybody hear something?
Can, but it's...
Should I try this one down there? Yeah.
You just yell, we'll repeat your question for the...
I've used the Autocomplete widget for a couple of projects now, and one thing that bothers me is I can't hit enter to select the first entry in the list. Is this a feature that will come, or...?
So the issue tracker is a great place to file requests like these. We really do respond to them. So yes, file that in the issue tracker. We will take a look at it. That's a great request. Thanks.
I guess it doesn't matter if I walk up to the mic now. We have an application that puts maps on people's websites for their business, and they enter an address, and then we geocode it in the back end, put the geocoded address directly into the map code on the website, and that prevents us from having to geocode every page load without doing any kind of crazy, memcache stuff on the page. But when we had adopted that practice, it was expressed to us that that wasn't necessarily a good practice for the reason that the geocoding gets updated from time to time, and we should be most of the time using the on-page geocoding, right in the JavaScript of the page. We chose to go the route that we went because we have another UI that users can then go in and change their map location. And since it's already hard-coded on the page, it's pretty trivial to hard-code it to a different address. Is that still considered not the best practice, or has that changed?
So the question is around, when is it best practice to geocode on the page versus ahead of time and then hard code that because geocodes update? I would say, so if you have a bunch of static addresses that need geocoding, they should be done ahead of time using the web service as you are. But yes, your cache should be cleared from time to time to allow for updates. So I don't have a recommendation for what that timing should be. If you notice that you're not getting the address you think you should, then decrease your cache time.
But this can be batched, remember, so.
This is something that the page gets generated, and then unless the user does something to trigger the page being regenerated, the map would not get updated anyway in our current implementation. We do have a mechanism that we can regenerate all of the pages if we feel like there's something that needs to be done. So we could implement like a
I would probably advise regenerating them from time to time so that you get updates to the geocodes. Any other questions? I think the mics are working now, so you can come up and use those.
I think you kind of covered this with the batching API, but my developers have talked about the rate limits and what are kind of your, it's a challenge. So what's your advice for dealing with rate limits?
So for a particular service, I guess it goes for all services perhaps, but I can tell you a little more about what I did in the Bunnings example around rate limits. So you'll notice that I was toggling between a bunch of options. And one thing that I did was just in the client, after I made a request, I cached the request that I made and then the end directions result, because otherwise it's rate limited, and so I can't make all those requests if you want to toggle back and forth across all the options. If you aren't doing, so anytime you're doing repeated things, you should cache in that instance so that you don't make the same request again and again. If it's not a matter of repeated action and just that you have more work to do, if you can front load some of that offline and storing it in your own cache, then that would be appropriate for, say, geocodes. Otherwise, wait.
Okay. Thank you.
Yep.
I have a similar problem. I have about 11,000 static locations in the United States, and every day about 1,000 dynamic locations. I'm trying to find the closest of my static locations for each dynamic. Can I use the distance matrix?
Distance matrix has a limit, I believe, of 10 origins, and it's not quite 10 origins and 10 destinations. Do you have the exact number? Yeah, you. Okay, so maximum of 100 elements in, whether that's 10 by 10. Oh, wait, new answer. So maps for business customers can do 25 by 25 or whatever that multiplies out to be, and not maps for business customers can get 10 by 10 or some other configuration that multiplies to 100. So is that the answer you were looking for?
Yeah, so really for a large number, like in my case, you don't really have a solution then?
I would say for a large company and a large data set, you should talk to our sales reps.
Okay. Thank you.
Thank you.
More questions around unit testing with the JavaScript API. I mean, there's some DOM manipulation at first, versus, I mean, there's stuff that you don't have to, versus maybe unit testing with events that you could trigger off a map. Any more thoughts on, is it possible to do that? What's the capabilities in depth more with JavaScript? And
let's see. I'll see if you may need to ask follow-up questions if I don't get all parts of this.
Okay.
If you use Google JS Test, for example, it runs not in a browser at all. It runs just the JavaScript. So that's a good tool to use for testing the functionality of your class. You can easily trigger events with it and listen to events and test your event handling. If you want to check things in the DOM, then Puppeteer is the way to go, and you can actually inspect individual elements and click on them. And so you can check that, you can actually load it up running the Maps API and check that the map has loaded and that you have done the things to it that you want to do.
I guess another key thing to say is that if you follow this sort of testing structure, then it actually guides your way to actually structure your individual classes as well. So if you can pull out all of the functionality that doesn't have to do with DOM manipulation into one class, then you can test that really easily and really quickly using Google JS Test. And then if you have the DOM manipulation, a separate thing, then you can test that when you're doing your overall integration tests in the browser with Puppeteer.
And with that, keep in mind that you can mock things in Google JS Test, meaning you can mock out all of our classes and just expect that a map works the way you think it should and a marker works the way you think it should, and trust us to have tested those parts and mock those out and just check that you're correctly calling set position or fit bounds or whatever it is that you are calling on the map.
any ways to get help on mocking the data?
So I think the resources for Google JS Test will explain how to create mocks. And it's actually as simple in JavaScript as saying create mock instance or create mock function, and you just pass it the name. So with externs, using the externs in combination with Google JS Test, you should be able to mock the Maps API functionality.
Okay, thanks.
You're welcome.
Hi, at the Federal Aviation Administration, my users are either searching for an airport code or an address. Could I use the Autocomplete widget to first check if it's a 3-digit airport code like SFO and try and autocomplete like airports that start with S, and then if not, go to the address suggestions?
In the back, do we have airport codes in autocomplete?
It usually works for airport codes, but we have, you know, like really minor airports that it doesn't work for.
Yeah. I think the short answer here is that though airports are in autocomplete, it's probably, we don't quite have a way to say restrict just to airports.
I have an internal list of my airport codes. Could I point it at my internal list first, or does it not allow for that kind of local
It doesn't,
data?
you cannot insert things into the autocomplete.
Okay, thanks.
But go ahead and file feature requests on the issue tracker.
All right, thanks.
And talk to Marcelo. Any more questions? All right, thank you very much. And there is a fireside chat this afternoon at 5:15 if you have any more questions for a broader range of people.